Now student, we are going to discuss question number 5.8, and in this question it is given to you a closely wound solenoid of 2000 turn and area of cross section 1.6 into 10 to the power minus 4 meter square carrying a current of 4 ampere is suspended from its center, allowing it to turn in an horizontal plane. Clear? Always keep in mind, whenever we have a solenoid, definitely number of turns will be given to you. Clear? Current that is flowing is also given and area is also given. So can we calculate here value of magnetic field? Yes, that is equal to mu naught Ni. N is the number of turns per unit length. This is a standard terms that you should keep in your mind. Clear? Or standard formula. But here what is our objective? Our objective here is to first calculate magnetic moment associated with solenoid. Clear? So how can we calculate? Actually we know formula of magnetic moment. This is given by NIA. N is what? Number of turns, I is a current and A is the area. So number of turns, I can say number of turns we have, this is 2000 multiply, I can say current that is equal to 4, and what about area? Area is given 1.6 into 10 to the power minus 4 meter square. Clear? So from here if you write here, we can write like this, 4 into we can say 16 into 100 into 10 to the power minus 4. Clear to you? This point remove, this 10 is cancelled out, 16 into 8, we can say 16 into 8 multiply 100 into 10 to the power minus 4. So from here you can write like this, we have, this is 8, we have 4, so 128. So from here we can write like this, this is 128 into 10 to the power minus 2. Clear? And this value we are getting in joule per Tesla. Clear? So from here I can write like this, this is 1.28 joule per Tesla. Clear to everyone? So this is all about part number A, magnetic moment. Clear? What is force acting? Now always remember, whenever we place any current carrying wire in a magnetic field, clear, at that time we know, and definitely when the current is flowing, what about the force? Force acting, it will be 0. Why? Because this is a closed loop. Clear? If you calculate here total force acting by a formula that F equal to BIL sin theta. Clear? For every small element you will find net force that is always acting either inward or outward direction, it depends on a current condition. Clear? And you will find always net force acting, that is 0. Clear? So always keep in mind, net force you will find that is 0. Clear? How this is possible? Let's suppose first I am taking here, let's suppose this is 1 turn. Clear? For 1 turn, let's suppose current is flowing like this and magnetic field is like this. Clear? So you can see if you use here right hand rule or left hand rule, whatever, so at that time let's suppose I am saying here the force is acting in this direction, here force will act in this direction, force will act in this direction like this. So now we can say one force is actually cancelled by another force. Clear? So directly we can say net force is 0. Clear? But what about net torque? Clear? Net torque we can say, because it is an objective here in this question, we have to calculate torque if uniform horizontal magnetic field it is given to you and it is set up at an angle of 30 degree with axis. So I can write like this, this is MB sine of theta. Clear? Value of M, magnetic moment, this is 1.28, value of magnetic field. Magnetic field value is given 7.5 into 10 to the power minus 2 and multiplied with, I can say, sine 30. Clear to everyone? Sine 30. So sine 30 means we can say this is 1 by 2 and this one is 0.64. So 0.64, clear, multiply 7.5 into 10 to the power minus 2, I can say this is Newton meter. Clear? Now we can simplify this expression. Yes. Now we can simplify value of torque. Clear? So we can write like this, this is 64 by 100 and multiplied with, because this is 7.5, you can write like this, if you multiply it with 10 and divide with 10. Clear? If you divide with 10, you can say this is 0.75, you can say this is 3 by 4 and I can say this is 10 to the power minus 1. Yes or no? I am multiplying with 10, dividing with 10. So if I divide, this is 0.75 multiplied with, so it becomes -1. Clear? So Newton meter. So from here you can say this one is what? 16. Clear? So we can say this is 48 multiply 10 to the power -3. Clear? 48 into 10 to the power -3 Newton meter. Clear? So this is value of torque that is acting on this solenoid. Clear? So this is all about this question, but actually here you should always keep in mind that here we writing here this M, and in M we already included here number of turns. Clear? So do not multiply it with again with number of turns. Clear? So this is all about this question.